Okay, so now a population of 100 foxes is introduced to the island when the population of rabbits has reached 1,000. Okay, so let me just, I like to underline, guys, important part. So at the start, there's 100, now they put 100 foxes, there's 1,000 rabbits. The population of rabbits and foxes, y is now foxes, can be modeled by these coupled differential equations. Okay, so x is rabbits, and y is foxes. It's worth writing that down just to remind you, so you remember which is which. Okay, it then says use Euler's method with a step size of 0.25 to find the population of foxes, and then the population of rabbits, and then the population of foxes 1 year after they were introduced. It says a step size of 0.25. This is Euler's method, guys. This is Euler's method for coupled systems. I argue this is a question that's fairly straightforward to do once you know how to do it, and once you've practiced it a number of times, because it takes, you've 6 marks here, which means you've about 6 minutes, and really you're going to see me struggle to do this in 6 minutes, and I've done quite a few of these. So yeah, practice with your calculator, and I have the luxury of using my calculator on my computer where I can actually type things. You've got your annoying calculator that you have to press the buttons. So definitely practice this question, guys. Okay, so how do we do it? Well, these are my couple differential equations. They are the f of x, y, and t part of Euler's method. So what we say is x of n plus 1 is equal to xn, so xn plus h, which is 0.25, it's the step length, h times this, which is xn times 2 minus 0.01 yn, and close the bracket. And then y of n plus 1 is equal to yn plus 0.25 yn times 0.0002 xn minus 0.8. So you may have seen, if you've seen my video on this whole thing, what's happening is the foxes have arrived and they're eating the rabbits, but as they eat the rabbits, there's not enough food, and therefore the population of foxes actually declines, and then the population of rabbits increases, and etc. etc. So that's why the rate of change of growth of the rabbits is dependent on how many foxes there are, and the rate of change, or the rate of growth, I should say, the rate of growth of the population of foxes is dependent on the rabbits. Anyway, so this is the Euler's method, and then what we just have to do is sub it in. So for t, we're going to have 0.25, because that's the step length, 0.5, 0.75, and 1. And then we're going to have our xn, and we're going to have our yn. Now our initial xn, our initial population of rabbits, is 1,000, because that's what he says here, 1,000. Our initial population of foxes is 100, because that's what he says here. Now to find all the rest of them, you have to use this. We have to use Euler's method. So here, I'm going to go into my spreadsheet. Now guys, this is the bit that takes time, right? So there's your t, xn, yn. This is my 0, 0.25, 0.5, 0.75, and 1. Our xn is 1,000, or x0 if you like, and our y0 is 100. Okay, now the next step is, this is where I have to do equals. Think of it like an Excel spreadsheet. I'm going to do equal the previous xn, which is this one, b1, plus 0.25 times b1 again, because it's xn again. So instead of xn, I'm going to do b1 times, open bracket, 2 minus 0.01, and instead of yn, I'm going to put c1, and I got to put times c1, like that, close bracket. Okay, 1250. So actually, even though there's 100 foxes introduced, the population of rabbits is still increasing. Okay, then for the next y, I have to again do equals. Yn is going to be C1, so it's C1 plus 0.25 times C1 again, times brackets 0.0002 times B1, by the way I'm following this guys, B1 minus 0.8, minus 0.8, close bracket, 85. So the population of foxes is actually dwindling because there's just not enough rabbits for them to eat or whatever. Okay, and then I just fill in this, so I can drag it down here like this, or, and they haven't filled because I need to do this one as well. If you click menu, data, fill, and then just drag this down like that, there you go. Okay, now these numbers, yeah, put them in here because that's like you're working, right? So this is 1250 1609, 1250 1609, 2119 2837. So 2119 2837. So I've rounded here 2837. If you put 2836, you'd still get the mark, I'm sure. 8573, 8573. I'm just rounding to the nearest fox here, really. 65 and 58. 65 and 58. Okay, therefore, well, for part one, the population of rabbits is 2837, and the population of foxes is 58. Okay, that's it. That's part B.